generic examples there. Okay, so I want to know a really like layman's term definition of what percent yield is. Don't read off the board. Say again? What do you mean by the yield, though? Okay, so the amount of products we made, right? So, give me something else.
Pancakes.
Pancakes. Elaborate.
So, the theoretical yield when you make pancakes, like you have a certain amount of each of the ingredients, and you should be able to make a certain amount of the pancake.
Yeah, like you look on the back of the stuff, and it's like, okay, 2 cups of pancake mix, I should be able to make 12 pancakes, right?
When you combine it, sometimes all the stuff doesn't mix together, and so you get like the lumps of flour inside the pancake, and that's like the actual yield.
So let's say theoretically I was supposed to be able to make 12 pancakes, right? But I'm pouring the batter, they're not all the same size, there's some error in how it's mixing, I want to make 10 pancakes, okay? So somebody's not getting the second pancake, right? It's not going to be me, I'm the one that made them. But what was my percent yield? No, I was supposed to make 12, but I only made 10. Calculate your percent yield. 10 out of 12, well what's the percent? Calculate. 83%, right? That's not bad. Okay. What if I was, sometimes I like try to be, a good wife and I'm making cookies or cupcakes or whatever. Okay, so I make 2 dozen cookies. I'm supposed to make 2 dozen cookies. Well, I always have to try the batter before just to make sure it's good because, sometimes it's not. So then the cookie dough some of it gets decomposed in my stomach. And then occasionally, I'll drop an accidental cookie on the floor and the dog gets it. Okay? So I only made 20 cookies, but I was supposed to make 24. What's my percent? Oh, really? That's pretty good. Okay, I probably should have known that. It's the same ratio. Okay, so that's still pretty good yield. What would be a really bad yield of cookies? 42%. Okay, so that means Enlo ate over half the batter. She's got a stomach ache because it's not good for you. And then you don't make very much. So what kind of yield do we want? High or low? We want high, right? But what kind of percent error do we want? Right, that's the one people get confused. They're like, am I talking about percent error or percent yield? Percent yield is we want high, percent error we want low. Okay, so I like to call theoretical yield the la-la land yield. We're not always going to make what we think we're going to make. It's just theoretically what we should be able to make. And we must calculate this. This must be calculated by stoichiometry. We're not given that in the problem. We have to calculate it ourselves. Okay? In the problem, though, I'm not going to be like, hey, Ethan, get up and can you go do this reaction real fast? We need to figure out how much we actually made. Because we don't have time for that. But we will be doing labs next week, which we will do this ourselves. But I will have to give you, in the problem, the actual yield. Because we're not going to get up and do the lab right then and there and go make some pancakes and be like, okay, I only made 9. What's my percent yield? So that's going to be given to you in the problem. Okay? So, the actual yield, like you guys were saying, 10 pancakes, over the theoretical yield, the 12 pancakes, times 100 is how you find your percent. So I'm going to consistently label this AY over TY times 100, and that will be how you find percent yield. So you're adding this to your notes already. Adding this to your notes. And just as a disclaimer, any units will work here, any of them. But they have to be the same unit top and bottom. If not, units won't work together and cancel. So it can be in moles, it can be in grams, or they can be in liters. But as long as it's grams per grams times 100, or moles per moles times 100, it will work out. Thumbs up and I can move on. Question?
So if you're given one and it's 2 different units, would you have to convert?
Yes, you'd have to convert one to the same unit so you can compare them. All right, thumbs up and I can move on. All right, so we do this lab in AP Chemistry. It's a 3-day lab, and they get extra credit for getting the best percent yield and the highest purity of their sample. Okay, so it's on, like Donkey Kong, right? It is on. We have to make sure that we're really good. So here's what happened this year. Somebody made their sample, and they brought all their crystals, and it's in a solution, and then somebody knocked the beaker over, spilled it on the lab tops, and it was cold, so the crystals crystallized on the countertop. So they were like, oh my gosh, I gotta get all the crystals. They're pathetically scraping the crystals off the counter because they're like, we have to get extra credit on this lab. Because labs are worth a lot for their grade. So, lab grade based on percent yield. I spent an hour pathetically scraping every last grain of the product off the glassware table and floor. Okay? Ask them about their Chem Wipe fetish. They're using Chem Wipes, which are lint-free wipes, to make sure everything's really clean and sterile before they do their labs because they want to make sure they get good percent air and percent yield. So they're constantly like, who cleaned this test tube? I'm like, honors county. So who cleaned this beaker? Honors county. Okay. So yeah, I do throw you guys under the bus because that's not me. Okay. And then this one, he's like, yeah, percent yield, 9.3%. 63%. Okay, so not so good. I would not want this. He's happy. He's crying inside. I don't know if you can see it. He's crying inside because he did not get percent yield. Good percent yield. Okay. This is funny to me. It's funny to me.
No, but it's funny because that's my life. That would be
Yeah. Okay. So
no, I'm the type of person that makes up 96.9.
So we don't make very much. Our percent yield's really bad. We quit our day job and we quit what we're doing because we're not good chemists. Okay. So every single time with me, how quick close your computer so I can make sure you're with me now because I know you're going to get there shortly. It's like in the next 2 minutes you'll be there. All right. So we have a question regarding percent yield. We're given some information. You with me, Will? Thanks. So we're given some information. But immediately I'm like, okay, well, I have to be able to make something. So what do I need to write first? I can write the givens and the question, but what else do I need to write kind of at the beginning?
The formula?
What do you mean by the formula? The balanced chemical equation, okay? So write this down for yourself. Every single time, at the very beginning of the problem, you have to have the given and the question, and you'll have the BCE. That's the chemical equation. If not, you can't do reaction stoichiometry because you don't have a reaction. All right, so before we move on, go ahead and write down all those items there, and then we'll talk. I hope you find something familiar on the board. We just wrote that down, didn't we? What's a reaction here? Magnesium.
Wait, there's a reaction.
Okay, it says the decomposition of magnesium chlorate, right? So Mg, C, L, O, 3, parentheses 2. Decomposes, Parker, what's this make?
Makes MgO.
No. You're trying to do the other one again.
Oh, you're chloride.
So magnesium,
CL.
chloride, MgCl2, and what's your other product? Oxygen diatomic. Good. Balance for me, Mac.
So 3 on the oxygen.
And we're good all the way, right? Okay. So, Garrett, what's one of the givens here? Okay, I'm just going to write that underneath that so I know that's talking about this compound. And then what's the other given? So which of these is the gas? Okay. Okay. And I didn't say this earlier. Scooch back for a second. The word that will generally be given with actual yield, this is a dead giveaway now, they'll say the student collected or achieved or something like that. They'll say like they got this much. So collected is the word you're looking for actual yield. Okay guys, what's the actual yield? Yeah, it says that they collected 3.0 liters of oxygen gas. So put AY. This is the actual yield. It's just the way that it was phrased because it's a dead giveaway that that's the actual yield. Okay? And what's, with all this given information, what are we supposed to find, Serena? Okay, so if we're supposed to find percent yield, the question is really, what's percent yield? How is it calculated?
It's the actual over
Theoretical. You're good? Good. Times 100, right? Okay, so which of these do we actually have already? Actual. So what's the real question? And with the theoretical yield being our question means what unit are we looking for? Because it's got to be the same value, right, or same unit. So our real question is our liters of oxygen theoretically, which I told you theoretically you have to do what to get? You have to do it? Sweet, right, you have to calculate, right? So, am I going to start with the actual yield or we're going to start with the magnesium chlorate? Right, so I'm going to start with this, 14.0 grams, magnesium chlorate. With me? Okay. Okay. So we have 14 grams magnesium chlorate. All right, guys, think on our mole map. Where am I? I'm on my grams, right? What's the only place I can go next? Okay, so I think you guys can calculate this for me real fast. Molar mass. 191.2 grams. So somebody was on the ball there. Thank you. Appreciate you. I know it's tedious to write out the identities of all these, but here we go. All right, so we've made it from grams to moles. So I made it from grams of magnesium chlorate to moles of itself. This is liters. So question, liters of O2. My stuff's getting all blended. That's what we're looking for, is liters of O2. Okay. All right, so now what not, guys? I don't care about magnesium chlorate. Switch it. So we're on the bridge now. We're going from what to what? Magnesium chlorate to oxygen. So the ratio is 1 to 3. So I'm writing what here? Top. 3 moles of oxygen for every 1 mole in this mole of magnesium chlorate. Because this is 1 magnesium chlorate for every 3 oxygens. Okay. Courtney, what's the next step? Remember, I'm looking for liters of O2. How do I go to liters? Ooh, we get to use 22.4 because we're talking about a what? Not this volume. We had volume yesterday and we didn't use 22.4.
It's a gas.
Yes, volume of a gas. Thank you. Okay, calculate. What's up?
You know, some of you already probably have calculated like
Guys, a couple people, I mean, I know you took calculators in my box. There was some graphing calculators in there. I don't know if somebody left one in there. Was there a graphing calculator that somebody took out? Really, is that me?
Yeah, I didn't get it.
Anybody else?
it's fine.
Do you have one? Guys, it's gotta be graphing. It's not the little stupid thing. Hold on. Jillian, I got you one. Alright guys, you guys solve for percent yield. Sorry, solve for percent yield. That's not the percent yield though.
Now it's stressful.
Alright, Garrett, what's the answer? 4.92 liters of O2 gas, and then give me how you find percent yield. So you're telling me that this is theoretical yield, right? Theoretically, calculation-wise, we're doing actual yield over theoretical yield times 100, and what was the actual yield again? 3. Liters. So times 100. 61% yield. Would you want that person in your lab group?
No.
Yes.
I mean, that's not bad.
That's like me.
Okay.
Wait, I missed
Guys, I can't hear all of you. Question.
What is considered like a really bad percent?
So I would say, like, in the real world, they're looking for, like, 50% yield. But in our world, where we have pretty easy labs compared to, like, research chemistry, we want, like, 80 to 90% yield at least. If you get over 100% yield, you have lied to me, because there's no way you can make over 100% yield.
I put
Okay?
in 110% for everything.
I believe it. I see it every day. Okay, so go ahead and open up your laptops, guys. Open up your laptops, go to my website. We're going to do, like, a quick activity. Oh, I have a joke for you. What's the most favorite plant?
A tree with that CO2 in it.
As you're close.
Oh, for real? Yes.
Stoichiometry. Work with the heart. Right, go to my website.
There's no internet connection.
Just bring it back my way. Oh, the internet's not working? Oh. Okay. Raise your hand if your internet's working. If your internet is working. Okay, so come on, Ethan, get up here. You're gonna be my hold on, let me reset this. So guys, we're gonna make some sandwiches. Ready? Make some sandwiches. Right, you guys tell him how many pieces of bread you want.
I want 3
Can I sit?
Dude, more than that. There's a lot of us.
I want 7.
Oh,
I want 400.
850.
How many will it give us?
Extra 20. Give me 20.
Okay, so there we go. All right, I'm gonna say you can only have 5 pieces of cheese. That's it.
Aww.
dude, we want 4.
I want
Hey
cheese.
guys, so what happened?
We got 1 cheese left
Why
over.
was there 1 cheese left over?
Because not enough bread.
Because we made 4. Why did we make 4?
Because you need 2 per 2 things.
Couldn't we just made like a double cheese sandwich?
No, the recipe is on the top. You cannot change my recipe. It is 2 pieces of bread, 1 piece of cheese makes 1 sandwich. Okay, keep going. Come up with a new ratio.
Well, why couldn't you make
We'll do 8 and 4 and it will work.
Okay, so it's obvious which one works harder. So we made a perfect, this is what it's called, a stoichiometrically correct ratio. Stoichiometrically correct ratio, 8 to 4, okay? Give me 4 pieces of bread. 4 pieces of bread, okay, so how many sandwiches do we make?
2.
Okay, who is controlling how many sandwiches we can make here?
Cheese.
Not Ethan. No. The recipe, but also which reagent, which reactant.
Both of them.
It's a limiting reagent.
Okay, hold on. I think I heard it. So Ethan, tell me what's going on here.
It's a limiting reagent.
Who's limiting us?
The bread.
Why?
Because you need to have so much bread, but you can only make so much sandwiches.
So what's the cheese?
The
It's
cheese.
just there to be there.
The cheese is the other
What's
reagent.
another word for non-limiting? It means I have
Excess.
excess reagent. Okay.
Oh.
Come on, Will. Come on.
All right.
Okay, thanks, man. Okay. All right, guys. Will's gonna make everybody peanut butter and jelly. Here's the bread. I'll make that real flat white bread. There we go. I got some slices of peanut butter for us. Okay. And then some slices of jelly. This is the next century of peanut butter and jelly. Okay. It's great. Okay. So, and guys, what's the recipe for PB&J?
Alright, you got 2 bread.
2 breads,
3 slices of
1
peanut butter.
PB, and 1 J. Okay, go. Guys, we gotta cheer them on. Let's go.
Come on now, you got it.
Come on.
Will, PB and JB.
Come on, man.
That's all that's left.
What? What'd you run out of?
Gosh, dogs.
Guys, we ran out of bread. What did he say? He was your turn.
There's a limit.
So the limiting reagent was what?
The bread.
And the excess reagents?
Peanut butter.
PB, isn't that always the case? Yeah. It is. Okay, thank you, sir. Thank you.
Yeah.
Guys, who wants one?
Now I want a peanut butter and jelly sandwich.
All right, so while you're kind of a little crazy, you have 1 minute stretch break. Go. 1 minute stretch break. What? No.
Yo, I can't touch them toes.
Okay, back to your seats. You guys didn't see my shoes?
I know.
Right there with on the board, everything, right? I'm almost on geometry tomorrow. Oh, next week's on lab. Oh, well, unless we have to homework.
I can't.
If we have to homework, we don't have to.
I really don't want to. Or
Well, if we,
You guys just, I don't want to. Are we gonna have a lot of homework over like?
I love your inquisitivity stuff. I will get to questions as soon as I see that you have written down what's on the board. Thank you. So, this is our last main topic from geometry. Just today. So we have s'mores lab on Monday, aka s'more geometry. Okay, so I have had no one bring in anything. I can bring in, I got marshmallows and graham crackers coming out of my ears. Please bring in chocolate because it's the limiting reagent. Okay, so you guys can bring in some things. I'll send out a reminder. Let me do that. I'll put a reminder on my phone to do that.
If you only bring chocolate for yourself, you have to
It would be great if you could share. Right, keep writing.
I would.
It's not. No. This is not happening. Right, one more. Hi. I don't know what time it is. Is it just a break that bubble? Yes. Guys, it's like a snowball effect. You guys can't focus after one silly comment. I wouldn't start. I'm glad we agree. Alright, so the idea is that we now understand that sometimes reactions, you make just a perfect amount that you want. Sometimes you'll have something that stops the process, stops the reaction. What is going to stop the reaction? The bread, right? Or the limiting reagent. I'm going to call that LR from now on because I make us time to write limiting reagent every time. And then there's one reactant or a number of reactants that can be in excess, like the P and D, right? Or PB and J. And that is going to usually end up as waste. So it's all mixed together at the end. So we had all the PB and all the J together. It'd be kind of gross, okay? So it would be all waste. So do you guys think I would want the expensive reagent as the limiting reagent or the excess reagent?
Excess.
So the excess expensive ones all just contaminated and all the other stuff. That may not be good.
The limiting, you only got a small amount.
So usually what they do, and this is in chemistry manufacturing plants, they always want the most expensive one to be the limiting because you want to run out of your expensive before it starts to get into the waste side of things and you have to dispose of it.
But then you gotta pay more money.
Well, this is just in a given reaction. So they're just going to put in just enough of the expensive one just to make what they want. So they're not overusing the expensive one.
Basically, there's more than that can.
Yeah, they've got more in the stock room, right? They've got more. So they want to put the waste, they want to put the cheap stuff that's just going to be thrown away at the end as the waste products. Okay? All right, so these are your set of instructions. I like to try to give you steps sometimes. And those are your steps that require you. Those are your steps to figure out who your limiting reagent is. So make sure that you're writing those down, and I'll write on the board as well. Alright, so the mental energy is high here because we are doing 2 more problems in class, but they're long because they take this process, just up a notch. So the very first thing we're doing for the LR process is we're getting to moles. Getting to moles. Get reactants to moles, some of them. Okay, the second step is after we get to moles, we do what?
Compare the reactions.
So we're using the ratio, we're comparing the reactants. Kind of heard both of those, so I'm going to compare reactants using ratio. Okay? And then the last step, and this is really the most important thing, is once we do all this stuff, we can figure out which of the reactants is the limiting reagent, and we will take that limiting reagent and use it for the rest of the problem-solving process. So once we figure out who the LR is, and we're going to use it for the rest of the problem. Okay. So, give me a thumbs up when I can move on. Because I have your steps on the board as well in my fancy handwriting here. Okay. So I think first of all, we're going to do one whole problem together. Write it down with me and then listen really well, annotate where I'm like maybe making extra comments. And then we're going to do one kind of on our own. Okay. That's it.
Alright.
You might want to halfway close your computer so I can make sure you're with me here. Okay. All right. So go ahead and write down your reaction first. Write down your BC. It's not a great day to do it, but it's the only day I have because we have a short week next week. Limiting reagent. High mental power.
Is it hard?
No, it's not hard, it's just long, that's all. This reaction was, yes. Iron would have a 3+ charge. It's gonna replace, yeah, it's gonna replace.
Copper C, right?
Hmm? All right, Madeline, get me started here.
Yeah.
Give me the just one of the reactants. Iron. Hunter, give me the other. NO3. No, that's sulfate and phosphate, so 4s. Nitrates are 3. Good. Serena, keep going.
Then it's copper plus iron, parentheses, nitrate, and 3 outside.
Okay. Alex, balance that for me. So just kind of tell me your thought process. You don't have to do it all at once.
Alright, well, I started out with the nitrate, so in the reactants, you only have 6, and then the product you have 9.
So you're looking at oxygen and the nitrate, right? So what do I need over here?
You need
A 3. So I'm going to elaborate there. You said the 9 or the 6. I'm just going to say 2 total nitrates and 3 total nitrates, and I think that makes it easier. So what do I need over here? 2, because 6 is the least common multiple from there. And then Josh, pick up.
You put 2 in front of
And nope.
that. No, 3 in front of that.
Yep. And what else?
Put 2 in front of the iron.
Thank you. Okay. Balance chemical equation done. Second step. Every time you write your balanced chemical equation, you're usually going to write down your givens and your questions. But here's the weird part about limiting reagent. This is the key sign that's the limiting reagent. It's whenever you have more than one given. Notice that here. If 3.6 grams of iron, okay, that's a given, reacts with 5 milliliters of 0.51 molar copper to nitrate. So there's 2 pieces of information. We have information about both reactants. That's when we have to get them both to moles so we can compare them collectively. So this is the key sign of LR problem, is when you have 2 reactants with both information given for them. So everybody take both of these independently to moles. You know how to do both of those. Now the molarity thing's still kind of fresh. It's a fresh wound from yesterday. But I think you can look at your notes and look for how to do the molarity part. Iron's 55.85.
We just have to get it for people.
Yep, get them both to moles. Get the iron to moles and get the copper to nitrate to moles. moles is this, Buzz? The iron. 0.0645. Give me like 2 more decimals here. 4, 6. Okay. Moles. I actually don't want to do sig figs yet because I'm gonna round now and I'm gonna round later and I'm gonna round again. I'm gonna have rounding error. I actually prefer more than this. So is it 644 what?
64461.
Okay. I'm holding this moles of iron. Okay. Everybody put a square or a circle, something like this. Label this exactly like I am and put the word have. I have this much iron before the reaction begins. Okay, this is how much iron I have to start with. Okay, how about copper to nitrate? How do I approach that one? Ethan.
So first you want to take
Okay, so I need to get liters of this, and then
and you have to go ahead and use the dimensional analysis.
so can you tell me how many? Yeah, I think we can all probably do this in our head. How many milliliters? I'm sorry. How many liters is 5 milliliters? I heard 0.005, right? Okay, so how many decimals am I moving this back? 3. And I can show my work for that using dimensional analysis, or I can just get on with the problem, right, and just go ahead and convert the liters. So let's go ahead and start with 0.00500 liters. Okay, and then you said use dimensional analysis and do what?
You have to put 1 liter on bottom and up liters, and on top you're going to want to put the 0.51 molarity.
Good. So that number means number of moles per 1 liter, right? Remember, molarity is actually a double unit. It's got 2 units in it. So 0.51 moles. 0.51 moles, and this was of who? Copper 2 nitrate. Okay, so now everybody can calculate moles there. Oh, 0.0255 moles of copper 2 nitrate. Okay, same thing I did here. Square it off, circle it, highlight, whatever, and put what on top? It's putting how much I'm given, right? How much I have. Okay, so I'm going to always reference this as the have-need method. What I've done so far, and you might want to annotate like you did on your notes here. I've gone to the reactant, I've gone both reactants to moles, and now I know how much I have of both of those reactants. Okay? Now what I'm going to do, and this is part's kind of special, so pay special attention here. Not like you haven't been already. Okay, so I know I need a ratio of, for every 2 irons, I need 3 copper 2 nitrates. For every 3 copper 2 nitrates, I need 2 irons. So I basically need a time and a half copper 2 nitrate compared to iron, right? And I can look at these numbers and I can't really tell, like, do I have enough of them to react? So what I'm going to do is I'm going to actually multiply by these ratios to figure out how much of the other reactant I need to fully react with all of this iron. I'm going to do the same thing here. I'm going to figure out how much of the other reactant I need to fully react with all the copper 2 nitrate. So instead of doing that math in my head, I'm just going to write it down. So what I do is I multiply by a ratio of, for every iron, I need a certain number of copper 2 nitrates. So what's the ratio? It's either 2 to 3 or 3 to 2, right? Okay, but I want to cancel out moles of iron, so I'm going to put moles of iron on the bottom. So what goes on the bottom? 2, and this is actually truly moles, right? I know it's just 2, but it's 2 moles of iron, and this goes, what goes on top? 3, right? So I'm comparing these two right here. 3 moles of copper 2 nitrate. I'm trying to squeeze my work on my board. Ugh. 3 moles of copper 2 nitrate. And some of you guys will just write the ratio without the units. And that's fine. I just know what you're talking about here. Alright, so I've given up on writing copper 2 nitrate now, but we're moving on. Go ahead and calculate that for me. What's 0.064464 times 3 over 2? What is it? 0966.
87.
Okay, I'll go 9. That works for me. Can we agree on this? Is this right? Okay. Moles of who? I'm sorry, I'm writing sideways. Copper 2 nitrate. Good. Okay. So this is how much, and everybody put this big and bold. This is how much I need of copper 2 nitrate. I need 0.096 and some change. So I need 0.096 and some change. How much do I have of copper 2 nitrate? Oh man, I only got 0.002. Whoa, I need a whole lot more. What's gonna happen? Hold on, am I gonna run out or am I gonna have excess? I only have this much, I need this much, right? So what's gonna happen? I'm gonna run out. Is copper 2 nitrate my limiting reagent or my excess reagent? Limiting, we already know which one it is, right? Now, I'm gonna do the same process for the other one just to prove me right. But since I know it and I've now got it in my head, I'm gonna write it right here and put LR above copper 2 nitrate, just so I don't forget who's the limiting reagent. Okay, let's do the same ratio thing on the other one. So here we go. What's the ratio for this next one? Who goes on bottom? The copper 2 nitrate. So yeah, you're right. The 3. Okay, so the 3 moles of copper 2 nitrate go on bottom, and 2. Yep. And that's what? 0.0. Say again. 0.0017. And this is moles of who? See, the copper cancels, right? So it's moles of iron. And what do I write on this one? Need. Okay. So this is how much I need of iron. That's basically me saying, for all of this copper 2 nitrate to react, I need that much iron. How much iron do I have? Right, this is why you're at need, right? Look how much I got, a plethora. I've got so much iron, I don't know what to do with it. I only need just a smidgen of it, right? So this one's going to be in excess. So you have to write have and need and compare them crosswise. And then after you figure out your limiting reagent and your excess, put them up here so we don't have to think about it anymore. So just put excess at the top. Okay, so which steps have we done here? And I figured out the LR, right? Okay, so now I'm going to solve the problem. So I'm going to figure out, I'm going to use that. I did not write this down yet. The very first step we did was find the have. The second step we did with using ratios, we found the need. And then we compared them. We compared the have and the need. And that gave us the answer to finding who the LR is. So now what we're going to do is for the rest of the problem, we're going to use the have of the LR. Use the have. Now where's that have of the LR? What number is that? How much? But it has to say have. Okay, I heard 2 different answers. So this is my have of my LR right here. Okay, make a star, highlight, smiley face, something. This is what we're starting with for the rest of the problem. Okay, so we really haven't even started the problem yet. We kind of just figured out how to start the problem. I know it's like depressing, I know, but we're gonna proceed. All right, so this is what I'm starting with. 0.00255 moles of copper 2 nitrate. Now, what was this problem? What are we even looking for? How much copper will precipitate? Well, what's it really asking for? How many grams of copper am I going to make? Right. Talk to the person next to you for about a minute if you need to kind of recap what we just did and then try to solve for this. You should know where we're starting with now. Talk first. It's long. It's just long. That's why you have to stay organized. You're starting with this.
Do we have to do another one?
I'm doing this first one with you. You guys are going to do one by yourself. Yeah. If not, you won't know it. Just try. Just try.
It's gonna be a long
No, it's like you're just finding out.
Wait, can you go on?
Do you know if we're gonna have a test?
I'll count.
This is like one. Are you doing that? So the ratio of
Yeah.
That's why we are learning how to process up front. You gotta like write down the process skills. That's like advice I can give. All right, guys. So I know you know that we're solving for copper, right? We're solving for copper. As I start here with this copper, and I'm sorry, copper 2 nitrate in moles. You tell me. I'm in moles, right? I'm ready to cross what? The bridge. So I'm crossing to what? To the other moles, right? So I'm crossing from this copper 2 nitrate to this straight copper. I know it's a 1-to-1 ratio, but what do I have to write here?
33.
33. Sorry, it's a little sideways. Just correct your head over. Okay. So 3 moles of copper for every 3 moles of copper 2 nitrate. And the question was actually asking for what? Grams. So it's my last step. 1 mole copper. Oh, I got 5. It's cool. Okay.
How did she not know that?
I use these same. I know a lot of them. I don't know. I couldn't even tell you
What is
every
the mass
12.01. Come on, give me something.
Okay, what's the mass of
No, don't get distracted. Don't do this to yourselves. Answer.
0.1620428.
I'm still stuck there. 0.126 grams.
Isn't it 160?
162.
Oh, I think you said 26. 162.
Yeah.
This would be sig figs. This would be, I believe, is it two sig figs? 3. Okay, I thought it was 0.51. Or is it point?
0.51.
Yeah, so it's 2 sig figs.
Oh, you go from that.
You gotta go from the initial given.
Why, Miss Emma, why are we not doing? Why did we not take things on?
Because all of this work up here, good question, guys. All this work up here is not the answer. It's just helping us find the starting point to the question.
Oh, I like the one
Okay.
given to you.
And this is grams. Okay. We need to finish this question. We're almost done.
We just finished.
We did what's limit to reagent? We did how much copper? Think about how to do this next one. Think about the bread and the sandwich example. Think about how to do this first.
This equation is excellent.
Well, you know you gotta talk.
You can't even disagree either.
What you just,
What I just what?
what you just take what you have and
All right, Alex has got it, guys. How much excess is left over? Tell me
like how to get it or the
how to get it.
Oh, you just take what you have and divide it by what you needed? Or the other way?
Subtract. Okay, so if I had nothing, I don't remember the example, but we had like 4 slices of cheese. We made 3 grilled cheese sandwiches. Okay, so 4 slices of cheese. That's how much I have. How much did I need to make the 3 grilled cheeses? I only needed 3, so I say 4 minus 3 gives me 1. It's just a subtraction problem. It's not even dimensional analysis. Okay, so who's excess? Iron's excess, right? Okay, how much do I have of iron?
0.06446.
Okay, so I'm going to do have minus need to get leftover. So have was 0.00, oh no, 0.64. Oh. 464 moles. Okay. How much did I need of iron? How much do I need of iron, guys? Look at your paper. 0.0017 moles. And how much is excess? 0.627. 27. Thanks. And technically, I'd have to convert that to grams, but I know you can do it yourselves. Okay. Okay. Before I take a question, the theory behind all this is you can start forgetting something an hour after you do it, unless you review it. An hour. You forget 70% of stuff in 2 days if you don't do something. This is why you have to practice chemistry every day. If not, you forget it. Or you forget. That's why I give you at least a little bit every day. Problem set 12, we're working on for 4 days. Okay. So before I take a question, hold on. You are getting ready to do this again. before another question, because I want to know that you can do it. Remember, I don't think I told this class, but we're at the peak of chemistry. Everything next week is lab, and then we'll do some more story chemistry kind of in lab-based things, and then it kind of goes down. It kind of gets easier after this. We have peaked. Yeah. Okay. So, question. Questions.
Oh, I don't understand like what you did in the black. Like I got lost when you started.
Okay. So after we figure out the limiting reagent, we have to start with this number to do the rest of our math to solve the question given to us, which is how much copper is precipitated, or grams of copper produced. So when it says when it's asking for grams of copper produced, it's talking about this copper here, and you have to solve it from one of these. Well, you're actually solving from your limiting reagents. We're using this, which is the moles here, and we converted from 3 moles of this to 3 moles of this using the mole ratio, and then we made it to grams. That was it. We just went from grams to moles to grams. Okay. So what I teach you, I expect that you can try to reproduce in some fashion. Yes. Okay.
Yes.
So here's your question.
Killer.
Here's your question. You have 10 minutes to get us done.
Oh no, I need a whole hour.
Well, I've been trying to do this one, but it's not
Baby steps, guys. Baby steps. Baby steps.
What is it? What is
Yeah, you just look at what it is.
Yes, and do this. You can rock it. Amina, stand up at the lab station. Bye. Goodbye. 107.87.
Oh, I gotta read the given. What about 5?
I don't remember. 20.
Yeah, I got one.
No. Yeah. No, it's not 200. Is it 200? No, it's a catalyst. That's good.
You said the rest was 400 milliliters or it was 10 liters?
400 milliliters needs to be converted to liters first. Okay, let me catch up. Ashton, now somebody else works.
Yeah, you're right.
Where are you at?
Number 3. Is this how much of the reaction?
FYI, that was 10 minutes. Keep going. That was already 10 minutes. You need to finish.
Well, you said we had 10 minutes.
I was hoping that you could get it done. My expectations are here. You gotta rise. Let's go. Great. Follow along. 3, 2, 1. Back to me. Shh. Matt, how many moles is this? Copper. Come on. 0.0393. Oh, so not 0.0.
That was
No,
right.
that was right. 0.0393. All right, I'm good with that. I'm good. Okay. So this is moles of copper, and you guys wrote half here. And then how did you get the moles of the other guy? What did you do with this? Okay, so that's 0.4 liters, and you multiplied it by 1 liter on bottom and what on top? 0.1. So 0.1 moles of silver nitrate and 1 liter on bottom. So how many moles of silver nitrate is that? 0.04 moles of silver nitrate, and that's how much you have. Yeah? Okay, so we got to have. What do we do next? Okay, so we use ratio. What ratio was here?
2 silver nitrate,
2 silver nitrates over
1 copper.
1 copper. So I'm going to put moles of silver nitrate because I got to be that extra person to make sure I get my units right on the paper. Okay, so how many, what is this?
0.0786
0.786 moles of who?
copper.
No.
Silver nitrate.
Silver nitrate. That's the silver nitrate. It's really ugly, but it's the silver nitrate. Okay. Alright. So you figure out who's on bottom. You figure out who's on bottom because copper has to cancel itself.
Okay.
So copper cancels, we get to silver nitrate. So this is how much we need of the other reactant. I can already figure out who the LR is. Compare. Need of silver nitrate to have a silver nitrate. What do you know about silver nitrate?
It's really cool.
Guys, focus. No, tell me, give me relevant information, please. There's more. Sorry, so I need way more. So what's going to happen? And I'm going to run out because I only have yay much, but I need this much. So I'm going to run out. So what do I know?
It's your LR.
It is the LR. It is the limiting reagent. So we write that down so we don't forget, and then we have to verify that by doing the other one. What goes on the bottom here? What goes on bottom? 2 for silver nitrate, good.
And then 1.
1 on top, and that is 0.02 moles of copper that I need. Okay. So what do I know? So you're verifying, right? So you're like, I have a lot, I only need a little, I'm going to have plenty, so this one's my excess.
So is there like doing that type of stuff that you already know?
Only because later on I ask how much the excess is left over, so that's when we do our have minus our need, so I have to get the need of the other just to get the rest of the problem here, okay? So, tell the person next to you, how do you start the problem?
Start the problem with the have. Start the problem with the have.
The have of what?
A, G,
Yes.
N, O,
Yes.
3.
Yes. Oh, come on. That's a crayon.
You got it.
Okay. I need the have of the LR. Okay, so this is my LR. So this is what I'm starting with right here. Moving on. Go ahead and move on. Solve for the rest of these. Boom, boom, boom. Yeah.
We have number 3.
Is that the first one?
How much of the reactant? Yeah.
It's on the board right here. Nathan, Olivia, Will, Aishi, focus.
Oh, yeah.
Do you know what the ratio is?
How much do reactant?
Gonna write 0.420 AgNO3 as dimensional enough. And then like start it out. But then we need the ratio. What's the ratio to?
Like I still have
Like figuring out what oh my gosh, it's 2. Is it 2? Tell me if it's 2. What's
The
2?
one that we didn't
The
have
ratio
minus
thing. What's 2?
The mole ratio is 1, 2. Oh, yeah. Yeah, I didn't come out. You're trying to start the problem?
Is it 2?
I mean, hold on.
And then you put 2 MOL of AgNO3, whatever.
Sure, you're into silk, right? Yeah, so it's 2 to 2, right? 2 to 2.
Yeah.
Oh my gosh, I was right.
You know what I mean? That's serious. This isn't a fun. Can we throw a party?
I don't know, I guess it's B.
No, are you surviving?
Guys, turn around. Turn around. Thank you. You're not focusing for me. Don't lie to me. I know, but have you guys finished?
Yeah.
Okay.
I can show you all the steps.
I don't believe it. I need you guys to focus.
Wait, so if I thought you did subtraction.
I'm doing. I've only made it this far.
So which one? Oh, that one. I thought you were talking about the one below.
Yo, I actually
I was
like
trying to
this.
do
Like, I'm not playing. I'm not focused on.
A, B, C. Okay, so I'm on.
Is this the how much?
Yeah.
You have to find the excess.
.039.
What's the half of that?
It's 0.0393453.
I'm a whole different, that works for me. Minus.
What is this talking about?
0.02. Minus right on. I just rounded to 0.02, but it's 0.019345.
Of copper, right?
Yeah.
You guys can convert that to grams. Much, yeah. It says much. Much leftovers. So,
Wait. Did I really like? Okay. Yeah.
how many grams is this?
I don't know, I haven't done the part. I have to do it myself.
Yeah. I have to finish this problem. It's a part of me now. I need to.
Okay, go down.
1 point what? 1.23. Alright. I need to get to percent yield. What's the actual yield of silver?
I got 12.
What's the actual yield of silver? No, check your distance. Actual yield of silver.
Actual.
You know how like we use this number?
Actual yield.
You have to use like this half to start with.
That's not me.
We use our other half.
I forgot what it was.
What was the theoretical yield of silver? 4.31. That's what that says right there. 4.31.
Wait. Time out. What is that? Right where you're headed.
This is excess.
Good afternoon. Thank you, students and faculty, for participating in this year's annual Pink Out Corn Drive. Collectively, our school has raised over $170. We would like to congratulate the Bachelor's first year class who donated the most money and will be receiving a Dunkin' Donuts delivery on Thursday morning. Thank you again, everyone who participated, and have a great weekend.
You have to do it to whatever. 84. Well, it's just what.
84.45.
Okay, I'm gonna talk about mine, but I was there at one point.
Yes.
It's got like ears on them.
So much more sense. I was so lost. Like I did 4 and I only 5 other classes.
Yeah, but it was like.
What time is it?
Okay, guys, listen as some people are wrapping up their own problems, okay? One, thank you for progressing. Some of you guys whined, but then you actually ended up being fine because you actually succeeded, and you should feel really good about yourself. Because like I said, we have peaked. What I'm looking for Monday are the video notes, right? The video notes that I put online yesterday. You have your notes to take with that. I'm looking for this Monday. I will take S12 6 through 9 on Wednesday if it helps you. But if you don't do a limiting reagent one, you're going to forget how to do it. Okay, so at least get 1 or 2 done if you need more time with that. You know we have a day off on Tuesday, which means I'll take Wednesday, okay? Put your laptops up.
Honestly, I just want to like say like
Another 10 minutes it took us.